Hello guys, in these videos I will introduce this is a pop to find the center point in CNC machine, and this is my DIY one, and you can see here this shine and this body is much narrower than the other pieces that are available on the market for purchasing. And all the stuff are made by myself. And in these episodes, in these videos, I will not explain the mechanism. For the mechanical parts, I will not detailedly explain, because this is my design, and I will mainly explain the electronic parts, because this one is wireless. You don't need to connect a lead wire, and this is a wooden covers I made to close it, and this I think is 10mm shine. And my CNC router machine is a smaller one that has the color of, I think, color 11. Yes. And my bigger one have largest color, as it has the ER20. Also can fit this shine. And for the accuracies, it still need to be improved, and I don't remember the accuracy of this because I built it for long times. I think almost 6 years ago, and you can see my schematic on my logbook. Here is my very poor logbook, and I go to here. This is today. You can see here a lot of stuff, and I actually because the accuracy is not very well, so I make it for long times, and all other things is quite success, but I put it down for years, and now I take it back and do some and recall my memories, and or say a revise of what I done before. And the battery installed in here, I use very small battery here, LR66. These 3 pieces installed here, and I can open it. For electronic parts, I can disclose the fixed stuff. There is connect. This is copper. This is for connection. Actually, I stay the old battery inside and make some rust there, and I do all the cleaning and put the new battery into it. The negative side on this, and here screw it up. This is steel, made of steel. This is aluminum, and this pole is metal, and you can see a notch there. So when there is some collision during the popping, I hope this will break first and not damage the inside mechanism. I have not tried this. And for the spare parts here, this is actually a ball bearing, and at that time I buy some different size ball bearing, and I use spot welding to make them together, these poles, metal poles, and here. At that time I remember I used a much larger capacitor and DIY a sparking electrical circuits and some fixture to do the welding of these two metal parts together, and it quite well, and it don't come out. Try different times, and now I can test it. When this pole touch and bend this, you can see the circuit connected. I use two LEDs, so when I install a machine, when it come different direction, I can see it. It have the signal for different size. It can, and for the Z direction or up and down, you can see it trigger. And also tell some things. I can tune this. What I say is, for movement of this left and right direction to trigger, I can fine tune it by this there, by 3 pieces, small screw there, here 1, here 2, and here 3. These 3 pieces, and I don't remember what this hole is. There are 2 holes here and also here. I think it is used to lock the internal mechanism, and I think it is not very good in waterproof, but I think it is well. And here you can see some glue is not quite good looking. And furthermore, there is a small jam screw here, or address screw here, and the use of it is to adjust the travels to trigger it. When I turn it more down, it will trigger faster and go back. Actually, it is to set the contact position. I think that's well for the explanation of this part, for the outside looking. And now go to the electronic. The electronics mainly include the wireless transmission and also the encoding, and because in transmission you need to have the code for the transmit and receive, so that both ends will recognize each others. So in the circuits there are two parts. One is for here for transmission, the signal out, and the next one, this one is the receiver. This installed in the spindle, and this one is installed in the control box, or that also very near the machine, or the machine side. On the in my machine is on the right side of machine. My machine is a router machine, and moving the settle on the side of settle among this it. And now I explain this one. This receiver is operated in 5 volt, and there are two lead wire here, you can see, come out from the box, and one is for voltage, is 5 volt. I now use this and connect to this rechargeable battery 5 volt. It's not very complicated. This one actually is connected to, you can say it's not important, but I also make it is for connection for the Z-axis limit switch. So the Z-axis limit switch will also signal this out, and let me explain that. And then another lead wire will go to the control box. I think I missed one lead wire here. Okay, and I will test it. Use battery here. It's much more clear here. Power it up. So this lamp LED lights up, and I can use this to test. And there is trigger on this side, you can see. Okay, I will move far away a little bit, so I bring it to see how much this unit can trigger. Sorry, the television set interrupted us by this signal. I turn down the speaker, but this signal also, because this is the I don't know. Anyway, this is the, it's not the infrared signal, it's the because the voltage or power is not correct for this transmitter, and I think it's enough if they are not very far away and in the machine. Okay, so now I'll open up this box and let you have the preview it. You can see the box is dirty. Actually it already installed on the machine for some times, and you can see quite a mess. I use the wires for connection, because this is the prototype. Let me turn off the power. You can see here, this is the encoder, and this is the buzzer, and this some resistor. Here is transistor, and another part is this is the receiver, wireless receiver, and one is transistor, and this is the antenna. I think I have one. You can see here, I think I have another one lead wire should come out from here to go to the lead wire, go to the CNC control box. And here I turn on the power again. And here is another terminal, and if I connect this, that's the, if there is the Z axis travel downward, go to for the two changes. That's not for this popping, for the popping the center position, for the usually for the two changes. I have also installed a auto two changer box in the router machine, and for them, for the actions, when after two changes, it need to have a offset of the, we have the tools that need to touch the offset setter, reset setter, and it will trigger the machine, and this will go to this end, the two wire of the two setter, and it will, you can see, it will this signal will also go to here. So this box will accept two signal, and then one line will go out to the control box to give it a signal. So I first assembly back this one. Test it again. Let's see if it works. Okay, it still function. Okay, I put it all aside, and then we'll go to the circuitry, and it's better for me to explain this box receiver, and this is the IC for decoding, and this is the receiver, the radio frequency receiver, 5 volt, and this is 18 cm longest antenna. Oh, this is it. You can see inside here in before. Actually, there's some extra pieces that I bought before. There's this one. This is the receiver. This bought us in a pair. You can see. So they are not bought in a pair, but they need to be in pair. And I don't remember how much the operating radio frequency is. I think it's 800 to 900 megahertz, and this signal will go to this decoder IC DIN, and and 5 volt is supplied here, and turn on the LED, and this will be positive, and this is the positive, and also this one is, and this is the ground, and here is the VT will give out the signal for receive. This is a red LED. There's this one. When signal receive, it will turn on. And this is the oscillator. It should be carefully choose, and I will discuss later. These two ends is the oscillator. This top before DIN. This D0 to D3 is the signal out. Whenever there is decoded signal, it will give out here and here. This will give the received signal, this will give the decoded signal. And this IC, the code, the name is this one, two version. I use SC2272. You can see here, these largest pieces over here. At that time, I only can buy this largest pieces format. You see it here? I can't see it very well. You see here? I'll turn it down here. Okay. So these are the extra circuits I developed. This decoder signal will come out here and make this NPN transistor have current flow here, and this current flow will make this 0 voltage. If no current flow, it will high 5 volt, something 5 volt here. And if this high, this PNP will not be connect. If this is low, when there is signal, it will connect. Current flow will go through here. V2 is the voltage here is 5 volt. This voltage is turned down from 5 volt to something. I remember use this variable resistor maximum at this 0 ohm. I don't remember. This style not very useful, just for prevent wrong current, wrong connection of current, or drop some voltage. So anyway, if there is signal, this have the current flow in PNP, and J here is the buzzer. This is the buzzer, and it will beat, have the sound beat. And at the same time, this path also go to here to junction output. One junction is go to the LS, is the limit switch of the Z axis. One will go to the controller box. There's my controller card is ESS internal card, one in Mark III. So here nothing, just stays some negative voltage, positive voltage. There is the connector for the lead wire, and red wire, green wire, no use. There is only 1, 2, 3, 4. This not connect. I don't remember. There should be one lead wire out to go to the controller box. For this oscillator resistor, I will talk later. That's all for this receiver box, wireless receiver box, and go to the transmitter. This is sorry for very poor recording of the information. Also, it consists of two important parts. One is the transmitter, and one is the encoder. And this transmitter is also have the 7 centimeter antenna. It was hidden inside in a coil, and this go to these little pieces. You can see. I don't know if now in the market you can still buy these two PC board. If you can buy them, because it's long time pieces. maybe they have the new version. So these small pieces was installed inside here, so you can see there is very little space there, and the signal will come out through this antenna out, and this also work in VCC. I think is something 5 volt, but I use 3 button cell. This is 1.5 times 3. I don't remember if I can install 4 pieces button cell or not. Actually, I'm now using 3 pieces, so it's 4.5 volt. If I use 4 pieces, this will go to 6 volt. So this is operated in, there is no record here. I think it's 5 volt. So you can see here, go to the VCC of the transmitter, and the data will come out from this path, from this IC. This IC also operate in same voltage. On positive side is number 16 pin, as well on one pin 1 is also in VCC voltage, and the ground is these 2 pieces, number 8, 7, and number 9. With this ground, and here no connection, all of them no connection. And this number 14 have the signal come out and turn on 2 LED, and this is the resistor current limiter 1 kΩ, and this encoder key, all of them, all 1, 2, 3. I don't remember, it should be connect here, but in the next photo there is no connection. I don't remember. They should be matched together. I can't check it out since this. I don't remember it. Sometimes in some circuit there is some resistor to connect them to ground. Anyway, here the last one, D3, have the resistor, this value, and the data come out is on 15 pin. This path go to the transmitter, and there is one trigger pin. It don't show. I think the trigger pin is on this voltage. That means if it is not trigger, there is no power draw from the battery. When it is hit, the poles hit on the workpiece and connect the circuits, there is signal go out, and I recorded the current draw when operation is 8.6 milliampere, is very low. So if this one is, the battery do not have leakage, it will have a long time for use. But unfortunately, so I put it for, let it let it in storage for I think for 5 or 6 years. The battery already there is some rusting or some liquid come out. I need to clean them out, and so it's better to take out the battery out if it's not for working for a long time. And the important thing is this value of the resistor. This one is 3.3 megaohm, and here is some data for the resistor for choosing. And go back to I think there is some here. I have a table here. There are different pieces of cooktop IC, so I choose this one 2260 and 2272. So when I choose .2 mega, this value 3.3 megahertz mega ohm, and it will operate in this wavelength 500 microsecond, and at the same time this one is 220k ohm. Yes, for this receiver 206k ohm, and this is I think yes, these are the closest values for them for in use. Anyway, the schematic of them was this, and as well here I show you the IC, the receiver IC. There's these pieces, these small pieces, this 2206R4. It's very small. No, I cannot see here. Be seen. Anyway, that's all the stuff here, and maybe in the next videos I will have the testing on the machines, and of course at that there have the poppings. For poppings there is a program to operate it. At that time I remember I already wrote a program for it, and in maybe next videos I will also introduce it. And thank you for your watching this video.